So in this video, we're going to look at the sine, cos and tan waves. So first of all, we'll start off with the sine wave and we'll look at how we describe this wave. So first of all, let's talk about the amplitude of this wave. And the amplitude is the distance from the midline of the wave to the peak or the trough of the wave. Now, what do I mean by midline first of all? Well, the midline, I'm going to highlight it here. And in the sine x wave, the midline of the wave is actually along the x-axis, okay? Now, it's not always along the x-axis. So, if I was to describe the midline, it is the line around which this wave fluctuates. So you can see that the distance from the, to show you here, the distance from here, which is the peak of the wave, so the uppermost part of the wave, to the midline, okay, is the same as the distance from the midline to the trough of the wave. This is the trough down here, the lowermost part of the wave. And so you can see that the sine wave is symmetrical around this midline. So the amplitude is the distance from the midline to the peak of the wave, which is along here, or to the trough of the wave, which is from the midline to there. And the distance for both of these is 1. So the amplitude of this wave is equal to 1. So we'll write that down. Amplitude equals 1. The period of the wave, on the other hand, is the number of radians it takes to complete one full cycle of the wave. So the period of this wave is 2 pi. Okay, and of course we know that it takes 2 pi radians to go the full way around the unit circle. So from the start of this wave, as it goes through its cycle, it goes into a peak, then it goes into a trough, and then it finishes up over here at 2 pi. So the period of this wave, if I'm to draw it in, is 2 pi radians, okay, from there to there. So the period is 2 pi radians. Now, you can investigate the period of the wave from any two equal points on the wave. So I could look at maybe starting my wave over here at minus pi over 4. And then if I go through a full cycle of the wave, I go through a peak and a trough, and I'm back at the same point where I started over here at 7 pi over 4. So I'll draw that in. 7 pi over 4 is where my cycle repeats itself. And again, I have a period of 2 pi. So just to show that, that's 7 pi over 4 minus pi over 4 is 7 pi over 4 plus pi over 4. That's 8 pi over 4, which of course is 2 pi. Okay, so the period of the wave, no matter where you investigate it from, if you find the difference between the 2 points on the wave, you'll find that it is the period of the wave once you have gone through one full cycle. And so the last thing I just want to note here is the range of this function. And the range and the amplitude can sometimes be mixed up, so we need to be careful. The range is the set of all possible outputs. And we know that the outputs of a function, we can look at those and investigate those along the y-axis. So that's the function axis, the y-axis. And I can see that the range of outputs of this function go from +1. So the range of this function is given as the range is going from -1 to +1. And I use those square brackets to show that -1 and +1 are included. So now that we know how to describe all the different parts of a wave, now let's look at the cosine wave. So side by side here, I'm showing you the sine x wave, which we've just investigated, and the cosine wave. And cosine is short for the complement of sine. And the cosine wave, or the cos wave, is very, very similar to the sine wave, just that it starts at a different point. Okay, so they're both referred to as sinusoidal waves, okay? They follow this kind of up and down symmetrical wave that goes in a cycle. So let's investigate why it is that the sine graph begins at 0 to here at the origin, but the cos graph begins at 1. Okay, and it links back to the unit circle, which I have down here. So the unit circle is a circle with a radius of 1, okay? And I know that 1 radian then is the angle that gives an arc length that's equal to the radius. So the arc length here of this sector is 1, and the radius is 1, so I have formed an angle of 1 radian. Okay, and I know that every point on the unit circle can be written as xy using the Cartesian coordinates, or I can also write them in polar form. And to write them in polar form, I write cos theta sine theta. And this is how I can tell where my sine graph and where my cos graph are going to start. So let's look at what happens when I have 0 radians, okay? So 0 radians would be just along this line here. So when I have 0 radians, the cos of 0, as I can see here, is 1 from my x-coordinate. So when my input is 0 radians, my output is 1 on my cos graph. However, when I look at the y-coordinate is 0. So when my input is 0 radians, my output is 0 here on the sine graph. Now let's go around to pi over 2. Pi over 2 is 90 degrees. So when I have a 90-degree angle, or an angle of pi over 2 radians, I can see here that the cos of the angle is 0. So when I input pi over 2, my cos is 0. But when I input pi over 2 into the sine function, I get an output of 1. Okay, my y-coordinate is 1, and I can see here that when I input pi over 2 into the sine function, I get 1. Okay, and you can follow that all the way around. When I have pi radians, cos is -1, you can see here. And when I have pi radians, sine is 0, and I can see that here. And you can follow that all the way around the unit circle to get back to 2 pi radians. So what you need to remember is that the sine graph always starts here at the origin at 0, but the cos graph always begins up here at 1. So now let's look at the tan graph. And to understand the tan graph, we need to remember that from page 13 of our formula and tables book, we know that the tan of any angle theta is equal to the sine of theta divided by the cos of theta. Okay, so that's going to give us a hint as to how to draw our tan graph. So let's first of all look at this formula, tan theta is sine theta over cos theta. So the first thing we need to think about is that anywhere where the denominator of this formula is equal to 0 is going to be undefined. Okay, if you have something divided by 0, that is undefined. And so we need to look at our cos graph and find where is our cos graph equal to 0. So the cos graph here, you should be able to tell by looking at it which one is cos and which one is sine. Of course, cos must be the red graph because cos begins at 1. And you know, I should be careful with my language here because, of course, both the sine and cos graphs are cyclical and they start at -infinity and they go to +infinity. So when I say that the graph begins at 1, what I'm saying is that when you look at 0, okay, when you look at your x input is 0, what's your y output? And the y output is 1 for cos and is 0 for sine. So when I'm saying it begins at 1, the cos graph begins at 1, I'm not being very accurate in what I'm saying, but hopefully you understand what I mean. And when cos is equal to 0, it's here at pi over 2, okay, pi over 2, and here at 3 pi over 2. So I know that my tan graph must be undefined when cos of theta is 0. So it's going to be undefined at pi over 2 and at 3 pi over 2. And I'm going to highlight that here on the tan graph. And of course we can see that the tan graph does not pass over these lines of pi over 2 or 3 pi over 2. And we call these vertical asymptotes. An asymptote is a line on the graph where the graph will approach that line, but will never, ever, ever reach that line. So the tan graph is trying to approach pi over 2 and 3 pi over 2, but it cannot exist at pi over 2 or 3 pi over 2 because tan of theta is undefined at those points. So next, let's investigate where are my sine and cos graphs positive. So if I want to look at where is sine and cos both positive, I can see that they're both positive in this part of the graph here, between 0 and pi over 2. So I know then that my tan graph is going to be positive between 0 and pi over 2, because a positive number divided by a positive number is equal to a positive number. That's just from my sine rules. So now let's look at my sine and cos graph between pi over 2 and pi. So sine is still positive, but cos is now negative, okay? And so between pi over 2 and pi, I have a positive divided by a negative. So I'm going to get negative, and therefore the graph of tan is negative between pi over 2 and pi. It goes back positive then between pi and 3 pi over 2, and that's because if I look at the sine graph between pi and 3 pi over 2, it's here, it is negative. And if I look at the cos graph between pi and 3 pi over 2, it is also negative. And sine divided by cos is a negative divided by a negative, and that gives us a positive tan. So tan graph is positive between pi and 3 pi over 2. So you can predict how the tan graph is going to look by investigating the sine and the cos graph.